Okay, well, I think I'm live. I don't know for sure, so hopefully this, let's see here. Let's go back to the main screen and see what we can see from the screen. All right, okay, so Lee's on here, yes, so I am ready to go. So I'm gonna get started. Sorry, I had the screen minimized, so I couldn't see your notes, Lee. All right, so first, I'm ShawnMeyers. I'm here to talk about how to expect more from your database storage. I know my accent sounds a little funny to some of you, but rest assured, I do actually have one of these. Yes, it does have my picture in it. So yes, I was actually born on the island. I just immigrated to the States back when I was a kid, young enough that my accent didn't take effect, or I have the American accent. All right, so let's get into PowerPoint. I'm going to spend about 15 minutes in PowerPoint, and we're doing some demos as well, because talking about what we're doing here with SQL integrated storage really only opens your eyes when you actually see it in action. All right, so first, expect more from your database storage, or for me, it's expect and get more from your database storage. Stop expecting it and actually have it delivered. So the next two slides I'm going to talk about basically is different perspectives. We have a DBA and we happen to have the infrastructure people. And we're going to talk about how they view infrastructure in general. So a DBA perspective versus the infrastructure perspective. And sometimes they clash, but our goal is to unite them to have one unified process to make things. So first thing I need to talk about at times is lack in time and skills. What I mean by that basically is DBAs have a lot of skills, but of course, like everybody in IT, nobody has any extra time these days. So what happens is that when we have performance issues that are usually sometimes related to storage processes, the DBA has to learn a lot about storage to figure this out, because the storage admin talks in storage processes and the DBA talks in transactions and other kind of things. The languages don't actually mesh. And so someone has to learn how to talk as a translator. In my previous lives, I was a consultant and I acted as that translator. But so the DBA spends a lot of time learning about storage, and then instead of just trusting the storage admins, and then the whole process, and it's a painful, especially when you get those large meetings when you have everybody in the room trying to talk about what's going on with the storage. And there was a lot of, hey, my silo, my stuff, my works was great, but overall we still have a problem. That's when we talk about that. Database slowdowns. So DBAs, we have a lot of rules to follow. Basically, we have a lot of data protection tasks. We have to refresh test dev systems. We have to do backups, and we also have maintenance systems. All those things tend to cause a slowdown of my production database. We don't want those, and that can show this tool how we can prevent many of those types of issues. Because right now, what it is, if you just manage not from a slowdown perspective, it's a let's just schedule for after hours when the load is less. Let's stop thinking about that. Let's do the work when it needs to be done, and because we can avoid the slowdown. Waiting on other staff. When I talk about this is, so DBAs, we do a good job of managing and monitoring systems and seeing when we're going to run out of storage space. The problem is, okay, now something unexpected happened. I used a whole bunch more storage, wasn't planning on it. Now I'm very tight on space. I need to open a ticket with the storage admin team. Storage admin goes, oh, look, okay, the LUN has some extra space. We can definitely grow this process, and then goes and creates, expands the data store. And then the VMware team takes it, looks at the data store, sees it's been expanded, goes ahead and makes and grows the process, and then logs into the VM and expands the vDisks. Now the Windows admin has to go log into the Windows machine and then go expand the drive. Now the DBA can go use that. If you're in a mid-sized to large companies, that's a week, if not 2 weeks of trouble tickets going through the system. Versus smaller companies, you actually do one person doing all that task, but it's still a lot of different tasks. You shouldn't have to do that. Next thing, inadequate visibility. All storage systems today, we cannot see per database metrics. We happen to have, most people have SQL servers have multiple databases on each SQL server, but we don't have metrics per database. We have metrics per LUN or volume. No way to go see that. And so what happens when we have performance issues, the most common thing is we just over provision everything. So what happens is you see systems out there with a 300 gig database with 2 terabytes of space allocated to it. It's wasteful and it's not providing the proper assets. And especially if we're looking to move to the cloud in the future, not knowing what we're actually using is going to really underestimate or overestimate your cloud costs. Knowing what you're actually using by having good visibility will help you with this. And then lastly, the unpredictable DB performance. And this is one of probably actually the biggest things to talk about. Database systems, Everything is shared. The database, the compute, the memory, of course, and all the storage. Plus, it's all shared with with usually in VMs nowadays. So we have VMware layers on there, and I've got shared with other VMs, which has other workloads on there. So when one thing has a spike or a high usage, i.e., someone put a bunch of VDI on here and put we just had a whole boot storm on that process, all my databases slow down. I have unpredictable performance. And we're going to show you how you can actually have consistent, predictable performance all the time for your databases. Now let's look at the other side, the infrastructure admin's perspective. Again, we kind of talked about invisibility. What happens is the DBA complains about, hey, my AdventureWorks database is slow. Storage person goes, where does it reside? So then we have to go find out, okay, so this person's put it on their D drive of this virtual machine, which resides on this data store, which now translates to this LUN, which through this WWN, now I can go look in my storage to go see where it's at. So I have to have a lot of translation steps in there. I either have to look it all up, or I spend gobs of time managing Excel spreadsheets to keeping track of all this stuff. Not a painful process, and it's not a difficult process, but it's a pain because it's a lot of extra work. No simple visibility of, hey, my AdventureWorks database, I can't just go in and go look at that. Again, next thing, performance-related inefficiencies, the bottlenecks. So again, we talked about over-provisioning, and that's what most common thing is I see is people just way over-provision. And the last thing with that, long-term planning, if I over-provision, all my planning steps, all my budgeting process, all my 3 to 5 year plans are all skewed because I really don't know. And the other thing is, DBAs can tell you how much space they used this year and how much they used last year, and we can do a trend analysis on space utilization. DBAs can't tell you how much performance they use. They won't be able to tell you I used 1,200 IOPS for this database or 3,000 IOPS. They don't know if they went from 300 to 5,000 in the past year. All the information, because you're going to run out of usually performance, not capacity with databases. And so it's very hard. Since we can now provide visibility per database in a performance scale, you can do your long-term planning and show you in our metrics kind of process. And then also, most storage or infrastructure admins have a hard time helping DBAs do things with data protection, mostly because all these snapshot stuff on most SANs cause I/O bottlenecks or I/O pauses or stuns, which DBAs can't live with, and we don't have those issues here. And then lastly, no per database QoS. You can provide great quality of service for each individual database, but you can't do it for each individual LUN, but you can't do it per database. With SQL integrated storage, we can. So how do we actually get here? So first, Chentry, many of you, if you're aware of Chentry, we are pioneers in managing basically per object, i.e. in this case, virtual machine, which we started off with. So we managed it at a virtual machine level, not a LUN level. And so we're going, hey, wait a minute, what's a virtual machine? A VM is just a collection of files. There's some metadata and it's attached to a hypervisor. So Chentry invented VMware storage, and we integrated with the hypervisors, and now things are fantastic for how you manage virtual machines. So we're sitting around going, what's a database? Oh yeah, it's just a collection of files. There's some metadata, and it's attached to a relational database management system. So can we use all the technology we have per virtual machine against per database? And of course, the answer is yes, which is why I'm here today talking about this. So now we're going to revolutionize how you think about basically managing storage for SQL Server databases. No longer I'm thinking about space and capacity processes. I now manage everything at a per database level, and I can do all kinds of facets for that. The biggest thing actually is the limitation of what you think you can do with this, because now you can probably do it all. So first, let's go back. Standard storage. Have a LUN level. So each one of these represents a virtual machine. I've got a LUN, which turns to be a data store, and of course, I've got 7 virtual machines on there. All of these happen to be SQL Server virtual machines. So VM store, we already did from a per VM level. We took the VM out and managed the VM as a unit of measurement for how we manage storage. Now on this database server, in this case, the diagram we have 6, but in reality, the median number of databases per SQL Server instance is between 10 and 12. We'll choose number 12. So on this data store, I've got 12 databases per which one of those things. I have 84 different databases. So if one person runs one bad query on one of those databases and it causes a massive I/O spike, all other 83 applications will be impacted and possibly slowed down because of the way of traditional storage works. So what we're doing now, we're taking the database out and allowing us to do the same thing. So now I'm going to manage it per database. So now if one person writes a really bad query, all other 83 applications in this kind of constant scenario would be unimpacted and unaffected and still operate. And that's where we're talking about some cool stuff. And also with this, now I'm doing per database options. I can do cloning faster than you can imagine. It takes me seconds to clone. I can clone as fast as I want to, as often as I want to. And now there's absolutely no excuse for not having at least one full database per developer. A lot of times what happens is devs work on a very small subset of the data, say 1,000 rows on their laptop, and they write their code. And they test it, works fine. Ship it off, goes off to QA. QA goes, just doesn't work. And what happens is, when I'm running on 1,000 rows, it's all sit in my memory. Guess what? Any horrifically bad written code will run and run properly. I now have 100 million rows to scan through to do this. The query now takes 35 minutes to get through. It should take 2 seconds. Because a developer doesn't have a full set of tests, they don't ever understand this, and they never learn techniques to properly write better T-SQL code. Now with this and dedupe processes from the storage layer, I can have every developer have their own copy. They can refresh it when they want on their own schedule, on demand, out on a schedule, however they want to, with any database at the database level, with no extra storage space wasted. So now things that used to have hundreds and hundreds of terabytes of space, I now, with dedupe compression, i.e. I make 20 copies of the same 2 terabyte database, guess what? It's still only 2 terabytes on my disk. So a developer makes a 5% delta on all the data records. I now have, with the compression and dedupe process, it may be a 1% growth on that 2 terabytes. Still, or 20 terabytes, or whatever the number we use. I still have lots of processes here. And of course, this will integrate with all your DevOps and any CI/CD tools you may have. So we can script all this process. You can through workflows, whatever you want, however you think you want to operate it, we can make this work for you. All right, let's go do a quick demo. Take a break from PowerPoint because I don't like PowerPoint. I like showing the cool stuff. All right. So here is TGC. This is what we talk about when we're at the Tentry side. I think you've seen a couple other people doing demonstrations showing you how TGC works. One of the biggest things here, all my managed objects, we're now mixing things together. So I go into settings, go add object manager type. Nope, it's already there. I didn't scroll over. And you see, I've got virtual machines and databases all mixed together on my screen. So I can go see that test 1 or one test is a database. That's a virtual machine. Things are mixed together here, and I can go spot and work on different things with different how I want to. Of course, we also create a databases tab, which allows us to only work on my databases. So what I'm going to do here real quick, let's go over to SQL Server. I've got 2 SQL servers. I've got a prod version and a dev version. Prod, we're going to take this AdventureWorks Data Warehouse database here. Right-click, choose Properties. I'm going to show you, this is a basically 330 gigabyte database. Lots of space on the system. All right, and it's on my prod server. My dev server, I already have an AdventureWorks GW here, but I don't have one for Tactile. So let's go over Tactile. Let's go create a new one here for just called Demo. I don't have a demo one either. So I'm gonna go back over to TGC, go to my SQL servers, choose my prod server I want to, pick the database I want to work with. In this case, I have multiples of the same name, so I have to go make sure it's up the right one, right-click, and clone. Only piece of information I need, well, we're going to change the name because I don't like the word clone name. This is the default it gives us. We're just going to call this demo clone. I always use clone in here because I have scripts to clean my clones up in the backside, so I don't have to clean my environment all I want to. So I can take a brand new snapshot or use any of my existing storage snapshots I have on this database. I recommend all production databases have a snapshot from a data recovery perspective, and I'll show you why in the next demo. What server we're on, this is where default. I want to switch to a different server. I'm going to select my dev server here. And then SMB shares. So we use this, basically the magic behind it all is using SMB. So I'm going to put my dev share and make a copy of it and click clone. Takes about 3 to 5 seconds to happen. It's done and complete. I go back over to SQL Server, right click, refresh, and now I have my demo clone. It is a full copy of that 330 gig database that quickly, that fast. And it's now my developer can go do this. I can provide them a PowerShell or REST API. They can now go do their clones on their systems as fast as they want to. And of course, if I go into my past dev server here and goes look at the thing, I don't actually have any data on it right now because we have a 10-minute polling interval, which is why I'm doing the demo now, just to show you, hopefully by the end of this data will be populated, and I show you we're not using any extra space by doing this. All right, back to PowerPoint. Everyone's favorite place to be. So with Chantry on SQL integrated storage, we want to exceed your expectations. And again, I keep talking to customers about this. The limitation is I've been doing it all this way all my life. It's so hard for me to stop thinking of how storage constructs normally are and start thinking in a new method of that database is the storage construct. So however I want to analyze it, look at it, dissect it, clone it, do whatever, protect it, replicate it, is now at a per database level. And so whatever workflow you have, we can talk to you and figure out how you want to flow, basically you move into it. So the biggest thing I talk about, unparalleled visibility. SQL Server offers some great details from the DMV virtual file stats on your SQL Server. And then you've got information from your SAN systems. Here, per database file, any metric you think you may want, we can show it to you, from the size, from the amount of IOPS it's operating, your reads versus writes, block size, 8K, 4K, 64K, whatever you want to. We can get you that information from today, right now, or historical. So when that ticket comes in saying, hey, it was slow half an hour ago, I can go look and see, hey, guess what? It wasn't slow from this perspective, and then it helps me eliminate things from a troubleshooting process. I'm not going to go through all of these, as you can read them probably faster than I can talk, and I already talk pretty fast. My favorite thing to talk about self-service empowerment. Let the developers do this work. Don't have storage administrators, infrastructure people, or DBAs doing all this stuff. I can offload it to the dev team. Give the dev team the tools and the power they want when they want to go do stuff. Stop being impeding them. Let them go at the speed they want to. These effortless zero impact data protection, meaning no stun snapshots. Many people have tried different storage combinations with helping SQL Server databases operate. And many vendors have some really cool tools out there. The problem is nearly all of them either do one of two things. One is it causes an IO stun, or two, 1 out of every 10 to 25 times, they do the process, they get a database corruption issue because they don't do things. And if you want to do a detailed demo, I can walk through all the different processes on that and how we've prevented it, and we can't ever have a database corruption issue from doing this. And the lastly is we're doing auto QoS, meaning each SQL Server database has its own QoS channel, its own IO channel with a QoS process. So the system will automatically reserve enough resources to meet your needs on how you've been doing things in the past, based upon machine learning and AI systems going forward. Another thing I talk about is just how much time you spend managing other storage. On the right here, we have Chantry VM Store, one giant pool of data. Each VM or each database or each container basically becomes its own managed object. And here we're doing per databases. They all sit in that one giant bucket, but the object is being managed, so the database is a process. On the left is traditional storage. In the old-fashioned days, spinning disks, we did RAID 10, RAID 5, and put different drives in different places. And then now, with new systems, we've got bronze tiers, gold tiers, silver tiers, whatever we want to call them, which is basically a definition of the storage and how much space we want to allocate for it, based upon our replication, our snapshot intervals, or whatever processes. The problem with these, of course, is one is I have to predefine it and figure out how much I'm going to have. And when one of those buckets fills up, I have a problem. So say if my silver tier was not big enough and it's out of space, I have no more unallocated space. I have to go find one of the other buckets that's already full of stuff or half full, take everything, move it off of there, reformat it, recreate the bucket for the silver, expand it all out, and then move stuff back. Painful, long, convoluted, wasteful. And then also, not to mention, for each of these buckets I have, if I might have 20, 30, 50 buckets in a large array system, I have to keep 10 to 30% headroom in each one of those buckets. Again, not overly helpful because it can be very wasteful in the storage space I'm using. I keep talking about this over and over because it's probably the most key thing to understand. Each database has its own IO channel. My HR database, my finance database, CRM database, what other database. So that way there's no intervention by anybody to do this, but the process will work. And so each IO requirements for each database is going to be met without having to do tuning. So the workload isolation is fantastic, and it saves so much time because I now have predictable, consistent performance. No more it was slow at 9 o'clock kind of tickets. No more, hey, we always have a slowdown whenever this happens, or it just automatically adjusts things for you as needed. We have the best analytics and stats you can ever imagine from a SQL Server database. And our Tentry analytics engine, I can show you history and trending. I can do you'd be amazed at what kind of data I can provide for you. And the DBAs are like, this is fantastic. It's the best thing you can ever have for understanding what you do and what your growth is on your database platforms. And this is our analytics engine where I talked about some of the screenshots on here. The biggest thing for me is the uptime performance, and then just making sure we can understand how we can lower operating expenses. This is one of my favorite diagrams. On the right is how I do for database protection. So if I want to replicate it somewhere or just do snapshots processes, I just go in the Tentry integrated SQL integrated storage system and just protect the database. There's 3 steps. I actually was given a demo of this tool to someone from the Microsoft SQL Server CAT team. These are the senior basic escalation engineers at Microsoft, and they do work on a lot of the future-facing stuff. But if you have a ticket, no one else can solve it, it gets up to the CAT team or the Tiger team, depends on who you want to talk to. Senior people at Microsoft, massively amazing DBAs, much better of a DBA than I am, but they're not storage people. I sat one of these people in front of the system, gave him control. He could figure out how to protect his database and replicate it inside the storage system. I put him in front of any competitor storage system and go, all right, go replicate this database to here. He is never going to be able to figure that out. He is not a storage person, doesn't understand storage constructs. Our UI is simple enough, even a DBA can do it. So on the left is actually taken from the manual from one of our competitors on how they'd have to go do all this stuff, from define their schedules to do the lung process and all these different steps to go figure it all out. Not easy to do, not simple. All right, Q&A. Let's go quick, see if there's any questions first. Nope, no questions so far. And back to some more demo until we run out of time, because I love to show this until I run out of time. One of my favorite things data protection wise, from either think about this from a standpoint of someone messed up or even from a malware attack kind of process. So I said every SQL Server database should have snapshots on it for data protection, which allows you to do amazingly fast recovery. So first here, I'm going to use my AdventureWorks, and I've got all these databases. So we happen to have a spelling error in our system. Instead of having the UI fix it properly, we're going to go in and try to go update it manually. This is all SQL Server stuff. DBAs do this all the time. So I go find out, yep, I have one record, and the last name was Meyerhoff. It should have been Myers. We had a typo, so I'm going to do an update statement. And the proper update statement's here on the screen. But when I run it, SQL Server doesn't give you the, hey, are you sure when you do changes? So I don't hide the whole thing. I leave the where clause off. And I run this query now. Wait a minute, I only wanted to update one record. It tells me it updated 20,000 records. Did I really mess up? Uh-oh, I look in my system. Now every single one of my customers has the last name of Myers. I have just messed up our production system. Uh-oh, now what do we do? So since, of course, I have snapshots, let's just make sure what SQL Server I'm on. I am on past prod. Since I have snapshots, I go to my SQL servers, I go to past prod, I'm going to take my AdventureWorks database, widen it out a little bit. I'm going to right click, I'm going to clone, I'm going to pick an older snapshot, like the one I was taken a couple hours ago kind of stuff, and dump it back into here, and we're going to call it AdventureWorks clone. As we've already seen how fast I can clone, I can do the same thing from a data recovery, oops, wrong place. Data recovery perspective. So now, I've now messed up. I've made a copy here. So now if I go up in here, refresh, you'll see there's a new database. It's I'm on past dev. Like, there it goes. So I'll go up in here, you'll see I actually have a new database now. Right click, choose refresh. I have a clone copy of it. So now if I go look at this, I happen to have all the right names here. So instead of replacing the database, because I have transactions going on, I happen to have a new customer just started, so I might have more records in here. So as a DBA now, I can go write what I call a join query. So I'm going to mine the data from the clone database and overwrite the data back into production databases to go fix it where the names or the IDs basically match. So we're going to run this quick query real quick. 19,000 my records this. If I go now back to my production database, hey, my last names, I've been fixed. I've been saved by this process. As I tell people, this gives me, I'll spend more time in a meeting discussing how we're going to solve our problem than actually fixing the problem. And this problem can happen all the time from, oh, yay, VPN issues. This problem happens all the time with systems from developers in the system, business analysts in the system. They don't pay attention to what they're doing. They make a mistake. Or worst case, you get a malware process, and now I have data protection. So since the malware doesn't know about my storage snapshots and the fact I'm replicating these per database, and I can replicate them to the cloud, at some point in the future, which allows me then to now I can go bring this database up online somewhere else. So I can have the database as a portable piece of as the object I'm managing now. That's how fast I can go fix that. So let's go look at some of these metrics now. So past dev. All right. So we created that demo clone. As you can see, that 330 gigabyte database is now using 1.8 megabytes of space. So very little amount of space. So I can create a clone per developer. So as you want to accelerate development and enable development, this tool can allow this work as fast as you want to and stuff. And then now metrics-wise, let's just go pick a different database that might have some metrics on it. Let's go find past prod. I actually have more metrics over here. But actually, databases. On this tab here, I have all my databases all in one place. So I can go look at all the different ones. I have 101 databases managed in a single pane of glass on multiple SQL servers. And I can quickly spot by which one's having latency issues. The cool thing is I can hover over and see what's using my latency. I can see someone's coming from my network and something's coming from contention inside my system, from a flash side, this kind of stuff. And I can see exactly where it's coming from. I can see how much IOPS each database is driving at that time. I can drill in from a metrics perspective and go look at my database and what it's been using over periods of time, for the past 8 hours, and say, hey, didn't do much at night, but you can see I've had some different spikes. I can do the breakdown of the IOPS versus my reads versus my writes. I've got a whole slew of metrics I can go push into here to go see what I actually want to go look at and compare on. If I need to break down into files, I even have the data versus the log file in here. So I can go see what my IO for the different systems are. Is it a log write issue because of, we're running out of write buffers kind of process? I can help troubleshoot anything that's from a SQL Server perspective, only my performance. Lots of different things in here. The metrics I have per database will help you solve any slowdown performance problems, because all-flash arrays did an amazing job of removing so many problems, except it didn't remove the problem. It just made things so fast it covered the problem up. Those problems are coming back up. So we're still having database performance problems, but we have no insight to solve it. And NVMe is faster, great. But the next generations are not going to be a revolutionary from spinning disk to all flash kind of step up. We're going to have to solve those problems and understand where the bottlenecks are. And with SQL integrated storage, I can definitely drill down and show you exactly where those problems are at. And we can lay out what's going on there with your SQL Server data from your third-party tools. And we can show you which query probably is causing your IO problems. And now you know what to go fix, kind of stuff. Or is it a network issue? Or is it some other issue besides you being a database issue? All right, it's about time to wrap up. I'm going to check one last time. Just any more questions? All right, 2-minute warning. No, I don't see any questions in the Q&A process. So I'm going to just say, if there's any questions, I can answer them real quick. If not, I will wrap up. And I want to say thank you for your time. And Lee, I really appreciate you inviting me, allowing me to be here and talk about SQL Server. As you can tell, I love to talk about SQL Server.